Welcome to Using Modules with Stella. My name is Karim Chichakly, and I will be showing you how to use modules in different ways, different features in Stella that help you use modules. The picture here is a picture of urban dynamics and the loops within them, all within modules and multiple levels of modules, by the way, but there's only the top level here. Before we start, you've got a little grab tab on the left that lets you mute. Well, you probably can't, you're probably muted, but lets you move the panel in and out of your way. If your audio is not working, please read this, audio setup. You can do audio testing on here to make sure everything's working. If you have any questions, please enter them in this box at the bottom and we will do our best to answer them. As an overview of what we're going to be covering, I'm going to introduce them, obviously. We're going to talk about how they extend the modeling process. We're going to talk about reusing them, how to build deeper hierarchical models, and about ghosts. And finally, we'll have a question period at the end. So what is a module? A module is a container, first and foremost. It contains a bunch of structure, and hopefully you're going to put structure that's related to each other, right? So we'll see examples, but you saw it in the first one. For example, we had workforce. Everything in there was related to the workforce. They're connected hierarchically. You have things here at the top level. We have modules that are at the top level. Then those modules can have more modules. This one has 2 more modules. This one has 2 more modules. This is the top level. This is the lowest level. So higher, we go this way. Lower, we go that way. We can have structure at any level, but I tend to keep all modules at a certain level, and then I'll structure at other levels. Sometimes you might have some utility modules at that lower level that don't do a lot but help. They have inputs and outputs just like your built-in functions. Well, built-in function has inputs and 1 output, but they have inputs and outputs. And they are organizational only. They help you organize your work so you can explain it to people. There are no levels that exist while the model's running. Doesn't impact at all. So here's an example. Very simple example based on what we're going to be going over actually pretty soon. We have housing demand in one module and we have housing supply in another. As housing demand goes up, supply goes down. Inside this module, this is not how it appears in the software. We have to open this module, but inside this module we have a bunch of structure. Inside this module, we also have a bunch of structure. Somehow they're connected, and the connection you can't see when you look at either one of these, but it's here. Demand for houses here is connected to this ghost variable here that's named housing demand dot demand for houses. So housing demand's the module name, there's a dot, and then there's the variable name. So that gives you a very quick introduction to how these work. Why do we want to use modules? Because if we have a hierarchical problem, they map very well to that. They let us functionally decompose our problem into smaller pieces that are well defined and that different people can work on, that you can test separately, which is here. It helps you improve your presentation of your model. It helps people understand your model. And as I said before, you can have multiple people work on different parts of your model, and they can just implement, this module and that module, someone else this module and that module, then you can tie them all together when you have a large model. They can also enable the reuse of common model structure pretty easily, which we'll show. And if a lot of people are working on different modules and they're in different files, which is an option, then your version control becomes easier. So before we go over this slide, I want to see how many people here have actually used modules. So I will ask you if you've used modules, and we'll leave that open for a short time. So those of you who have, please be patient while we talk about some of the stuff for the people who haven't. At this point, it looks like about 65%, it's dropping a little, haven't, and the rest of you have. So I'll close that poll. We'll continue. Okay, so these are module symbols, these round cornered rectangles. And the name, I drag the name into the middle. It's normally on the top, just as it is with a stock. Inside any module, you can have what's called a module output. This is just a converter. I made it a module output. I'll show you how we do that. And it gets an O in it. It gets an inner circle to show module output. Although if it's a stock, it's a rectangle. It follows the shape. Okay, so here it's demand for houses. On this side, we can say we want an input. We want some input. We can create a placeholder. In this case, we call it demand inside this module. And we can say we want input from somewhere else for this, but we can assign an equation here and we can test this without connecting it up. But once we do connect it up, we have an assigned module input, and it has, as I showed before, the name of the module, a dot, and then the name of the variable in that original module. It looks like a ghost. This is in bold to tell you haven't assigned it yet and to remind you. And once it's assigned, it looks like a bolded ghost. It comes from somewhere else. By the way, module names have to be unique across the entire model. Variable names are unique within each module, but module names are unique across the entire model because we don't say housing demand was in another module. We don't create these long variable names. That's the main reason why we did that. So let's move along to what the modeling process looks like when you're using modules. Just normal using modules, not trying to go crazy like we will later and build much bigger models. So the modeling process, just to review, this is the standard process. We draw a reference node, we develop a dynamic hypothesis, we build the model, we verify it, we analyze it, and then we perform policy experiments. We're going to look at how it impacts developing the dynamic hypothesis and building the model. And we will touch a little bit on testing it and verifying it. We're going to use as an example I used a long time ago, 2008 or 9, about the modeling housing supply and demand in the 2000s. We're going to start by building the dynamic hypothesis, and then we're going to build out the model. I'm not going to show you the reference mode, even though I have it. I'm just going to save a little bit of time. And we're having an assumption. Back at that time, mortgages were mortgages that had a short fixed rate time and then started floating were very popular. And that time frame could be 3 years or 5 years, depending upon what mortgage you got. But 3 years wasn't unusual, very common. And then it was no longer a fixed rate. It was a variable rate. So all of a sudden you had a fixed rate that you could afford, and if it became variable rate and you couldn't afford it, you were in trouble. This model is, if you want to use the interfaces here, please don't do it right now. We're going to go through all this and then you can see. And if you wanted to download the model, it's actually number 10 in our sample models, which is here. You can get to this quickly. By the way, you can get to this and this very quickly by going to our website, going under resources and selecting sample models and look for number 10. Okay, so let us go build this model. I am in Stella. Hopefully you can see that I'm in Stella. And the module symbol is right here. So we will select a module and we will put it down and we will name that module housing supply. Oops. And I'll drag it to the middle, fine. And we'll create another module over here and I will call that housing demand. Now we already know from the other slide that there's a connector between these two. Maybe you're thinking it goes this way, but remember demand was on the left before, so it goes that way. And we also know it's opposite. It's a negative polarity here. We're just going to go back to this. Okay, so housing supply, as demand goes up, supply goes down because presumably the supply is being used up. We also have housing price. As supply goes up, what happens? Well, demand, I hope, goes down. As price goes up, supply tends to go up. As price goes up, demand goes down. And as demand goes up, price goes up. So we end up with these balancing loops here. There's one. I'm not going to set the colors I normally do because we're going to switch to another place in a minute. But here we have our dynamic hypothesis, okay, for this model. And you don't see the reference mode, so I'm not going to go through explaining why this is correct for that reason. You can also I went to the style panel here. So this is model settings here. By the way, if you don't know where this label came from, it's under the text box here. It was, when you open the model, it's set to this, but you can just pick the loop label here. And if you don't understand where I set the polarities, I can right click on here to set the polarity, and I can change its placement. Or when I select it, it shows up in the panel here, and I can do the same thing right here over on the right side. Now, at the bottom here, I have a bunch of things. I have model settings, and if I go over to the style one, which is this paint roller, I get, sizes of things that show up on here. I can do it individually, or I can do it across the board. I'm just going to do it across the board. I can change the modules to name only here, all of them. And when I do, it looks more like a CLD, right? So that's kind of useful, I guess, if I want to take a picture of it, I guess, or copy it somewhere. But I actually want to be building a model. That's my goal. So I don't want them to look like that. I want them to look like modules. This is my dynamic hypothesis at the high level, but inside I'm going to build models. So inside each module. So let's look at the module panel for a second, just so that you know what's going on here. I can't double click to select this, by the way, as I can for everything else. I need to single click it and have the panel open. Panel close, panel open, has to be open. Lets me set a name, lets me set a label for it if I want a label that's different from the name. It lets me set an indicator variable if I want to graph one of the variables inside on top of the module so that at this level I can see things happening. I can do that here. I can save it in a separate file, which we'll play with in a minute after we have something to save. I can password protect. I can import a picture. By the way, let's just look at what a picture would look like. I have a picture way over here. There we go. So here I put pictures in each one of these modules to represent what they were. It makes it very easy for someone to understand what they're looking at. Okay, so there's more here. There's this ability to import a model into my module, which I will show you, but not the second. I first want to talk about how we enter a model. So a model, we can double click on it, or we can right click and choose open module. There's also peek into module. That gives me this little picture here, but there's nothing in there, so we don't see anything. These are all empty. So I am in this first module. I haven't put any structure in there, right? I just created the modules. I haven't put stocks and flows or other modules or anything in there. But I have a new canvas I can draw on now that's underneath this module and somehow has to take these connections and provide stuff to those guys. We know that. When I'm in here, how do I know I'm in a module? This is an important question. Well, first of all, at the top, we have the name of the module next to the file name in square brackets. Secondly, these things appear on the side of the tool palette. The one on the right takes us up one level. The one next to it takes us to the top level, wherever that is, but it's the same as going up one level in this case. So that's how we navigate. We can double click or right click open to get into it. I believe there might be an open in the model menu too. No. Okay. So we can, to get into it and then to leave, we can press one of these buttons to get us out, whether we want to go up one level or all the way to the top. And there's also under the window menu, there's a module navigation panel. And so in the module navigation panel, I can go directly to any module. They're all empty, so I'm not going to see anything, but you will see this says housing supply. If I click on this one, I'm now in housing price. I can go back to the top level using that as well. Okay, so we just talked about navigation. We talked about pictures. We talked about the panel. Let's actually go use the panel to do something. I have another model sitting here that looks just like this that's already partially populated. If we can find it. There it is. Okay, so this is the same thing, but I've partially populated it. For example, if I go into housing demand, you will see I have some structure. If I go into housing price, you will see I have some structure. If I go into housing supply, there's, oops, not supposed to be anything. So we'll get rid of that. There's not supposed to be anything. As from testing earlier, sorry. So anyway, if we go into housing supply, there's nothing. So how do we get something in here? How do we fix this? Well, first of all, we have some errors. We say we don't have any inputs from houses for houses available. We have an input here called houses available here. And we know it's an input because it's marked. How did it become an input? I don't know. We'll go back to that in a second. But it's not connected to anything. And then this has errors because it's getting things from connections from housing price and housing demand, right? This connector and this connector, but it's not using them because it's in fact empty. So we could start building our model here, right? We put down a stock, we put down a flow, et cetera, et cetera. We're not going to do that. That's going to take way too much time. We don't have that much time. Instead, we are going to look at a pre-built housing supply model, which is right here. We can run this. This has, so inputs. It has demand as an input, and it steps up. So it starts in steady state at 110 and then steps up to 120. Price does the same thing. It starts in steady state at 100 and then steps up at time 5. And we can see and we can test this model. We can see what happens if we lower the normal price, if we increase the normal price. We can play with this model, right? If we speed up the time that houses turn over, anyway, if we change how long it takes to build one over here, etc. So we can mess with this and play with it all we want. This says no inputs or outputs labeled on it. So let's go back to our actual real slides somewhere here. Here's that same module. And this has the inputs and outputs already labeled. So they are here. Those are the inputs. And that is the output. So I need to somehow do that in this other thing that I have because that's my goal. If I go back to this, these were module inputs, and this was a module input, and this was an output. I'm going to leave the output alone for now, but I'm going to make all these inputs so that when I import it, I know what I'm trying to connect to. To do that, I right-click on it, and I say Module. Under Module, it says an input, an output, or neither. So I make it an input, and notice it's now bolded. Now, I have an equation in here because I can test it, right? I don't have to have an equation, but I do have an equation. So that helps me test it. Same here, I can make it an input. And same here, I can make it an input. Now, that those are inputs and I import it, they'll still be inputs and I'll know what I need to connect to. I can go and make this an output, but we're going to do that after we import it. So let's go back to our actual model here. And let's import that, which we do by clicking the import button for the module. And there it is. I'm going to import it. I still have errors, that's fine, but you see they're all there. Now, how do I connect them? I'm just going to show you the simplest way to connect them since I pre-built this externally, right? I built this before I did all the rest of this, or I built it separately, or someone else built it, and now I have to connect it. This isn't, if I'm building the whole thing from scratch in a small model myself, this is not how I would do it, and I'll show you that in a second. But someone created this separately. These are the inputs. Now I need to connect it up. How do I do it? Well, under module is assign input to. And what do I think price will be assigned to? Well, it's going to be assigned to housing price. And we can see it is. And normal price will be assigned to housing price, normal price. Notice this has already been chosen, so we can't select it again. And that leaves us with just one thing, which I hope is housing demand, right? Demand for houses, and it is. So those are all connected. I still have problems, though, if I go back up here. I've partially connected things. Housing supply is happy. Housing demand is happy. But housing price is not happy, and it says that houses available is not connected. So let's connect it. Oh, look, there's no way to connect it. There are no options to connect it. And the reason why there are no options to connect it is because there are no variables that are connected to me that I can connect to. So that's because I did not make this an output. If I make this an output, module provides output. Okay, now it has a dashed interior border. That means it hasn't been assigned anywhere yet. Then I go in here and I can assign it. Now it's assigned, and I can go back quickly by saying navigate to output. And that takes me right back to where the output is. Notice the border is now solid, which tells me it's assigned. Now, this is not how I'd normally do this if I were building a model from scratch, because it requires me to go through and explicitly set things to module inputs and module outputs and then assign them. By the way, if something's available, if this were not an input already and I had an available assignment, let's just do that, okay? I'm going to make this not an input. It will automatically make it an input for me, so I can, in that case, just assign things if I want, and it'll do that. But typically, if I'm building a bigger model myself, I'm not having separate pieces developed by people, I'm not going to do that ever, almost never. I'm going to go into here, and let's say this is not anything also at this point, and I'm going to use the ghost tool, which is here, and I'm going to ghost it just as I would ghost any other variable. Okay, I have a ghost. I'm going to go back up. I'm not going to click in the middle because that's a name. And if I double click here, I'm going to get the name selected. I'm going to go to the edge, double click, and I'm going to drop that here. And it's all going to work. By the way, why did it work? It worked because the variable I deleted here before was called houses available, and the default name that when I use the ghost is for here is also houses available. So when I connected it, houses available was already connected, already in the equation, and everything just worked. That's not normally going to be true. You're going to need to probably mess with your equation. Maybe not. Well, you will, because you're not going to have this equation written yet because you're just ghosting things to put them in there. So that's the fast way to connect things without having to set module input, module output, or anything. And when you do that, it creates connectors if they aren't there. Notice it did make this a module output again. So far so good, right? I did say, before I go on to running things and testing things, I did say I was going to talk about saving in a separate file. If I say I want to save this in a separate file, like so, and I'll use this name, fine. I can give it a different name if I don't like that name. And then I save this file. When I go to my directory somewhere here it is, I now have a new folder that wasn't there before. Now, you don't know it wasn't there before, but trust me, it wasn't there before. That is the name of my model, housing, supply, and demand demo with underscore modules. And inside here, I have that the model. That's where I'm pulling it from. I need that. If I pass this model to anyone else, I need to include this folder, which I can easily do by creating a package under the file menu, or I can just include it myself in my own zip file. So if I open this, we will see that if it ever gets there, My computer's feeling a little overworked right now. It's going to complain that it's open, which it is because I have the other model open. Oh, I just did it. I did do it twice. Okay, so we will open it as a copy, and we can see it's here, and that is that file. Okay, so I will go back to here, and I'll set it back to the way it was because I don't, oops, I double-clicked, sorry. And I don't want to save it in a separate file, and now it will be back in the original file. Okay, the one thing I haven't shown you is how to test this individually. So right now, I can run the whole model, but let's say I can't. Let's just say I'll do that just to break it. So now I can't run the whole model. But let's say I want to test this, just this module. If I go back to the model settings, the second tab here is my partial simulation setup. And it's set to run everything, but I can run selected modules. And cascade just means if I select the module, run everything underneath it as well. But we don't have top levels, the only one where that's going to happen. And I want to run, this is housing supply, correct? So I'm going to select that. And you'll notice now that the run button on the over here, this run button has a little module symbol next to it, which means I'm only running this module. And if I run it now, this is what I get because, well, it's in steady state, so we're not going to see much right now. I'd have to throw something out of whack. And I also have a pause interval. I could throw this out of whack. I can do all kinds of things, but we're not going to do that. I just want to show you that I can run this by itself. Actually, let me just do that again. We'll stop it. We don't have to go all the way. And you can see, you know, this isn't even defined. I didn't run this. This didn't run. Only this ran, and it has a little check mark to remind me of that at the top level. And also to remind me that I'm in that mode, which I can turn off. But I'm not going to bother because I want to show you something else. We're going to expand this model, and I'm not going to go over the process of expanding that model, but we're going to expand this model to include mortgages. And because the issue here is mortgages, right? 30-year mortgages that have a 3-year fixed rate and then start floating. So we have a bunch of loops here now. We have this original loop here. We have a loop here that goes through mortgages all the way around. We have another loop here that goes around on the other side through demand, mortgage, and housing price. We have this inner loop here, and we have the loop around the whole thing. So we have a bunch of loops. By the way, I did that using the loop tool. Loop label doesn't just let you draw these, but lets you select, if you want to, what's in the loop. So when you hover over it, you can see what's in there. Like here, it's confusing. Which is B3 and which is B4? So I intentionally selected everything so we know. And what's B2 versus B5? I don't know. I could give them names, of course. In any case, if we look at mortgage demand very quickly, we'll notice there's this deregulation switch. And what the deregulation switch does is what happened in the 2000s. They let them approve more mortgages even though the conditions aren't right for doing that. And then there's a period where they're a locked mortgage, which is set to 3 years, I believe, right now. Yes, 3 years. And then it's a variable mortgage after that. And the rate changes, the rate floats. So with this model, we'll go to the interface just to play around very quickly. We're going to run it first to show that it's in equilibrium, and then we're going to kick it out of equilibrium, and we're going to see what happens. I probably should have left this open because my computer is working very hard to share screens. There we go. And this is the, I guess it was in 2008. This is the model you'll see at that link. If we run it, you'll see it's in steady state, okay? I don't need to keep going. It's going to all be in steady state. Nothing's changing. So we'll skip that, and I'm going to decrease the interest rate and turn on deregulation. And I would like to know what you think is going to happen when we lower the interest rate. So we'll launch another poll for that. The choices are defaults will go up, the price will go up, defaults will go down, price will go down, price will go up and defaults will go down. Which one of those do you think is true? Or more, I guess the last selection gives you multiple options. So the overwhelming number of answers are, people selected price will go up and defaults will go down. The second most common answer is price will go up, and then they're scattering of answers between all the others. So let's just say the choice is probably between price will go up and defaults will go down, or just price will go up. So let's just see what happens. Let's just run it. So I'll just run it a little way so we know. This is price, so price certainly went up. This is defaults. Have defaults changed at all? No. So price went up, defaults did not change. Price went up because now demand went up, right? More people can afford it at the lower interest rate. Now we're going to raise the interest rate again. It was down 5 points. Now it's only down 1 point from what it was when we started. What do you think is going to happen now? So price will go up, defaults will go down, price will go down, defaults will go up, price will go down, and defaults will go up. Those are your choices. Lots of choices. Again, you're trying to choose the best choice of all those options. More than one could be true. So there's kind of an even spread here so far. I'm going to wait a few more seconds, see what happens. Okay, so price will go down is very popular, as is price will go down and defaults will go up. Price will go up and defaults will go up are also almost as popular. So let's just see what actually does happen. Yeah, it's neck and neck between price will go down and defaults will go up. And then right behind that is price will go up. Okay, so let's just see what happens. I raised that to only 1 point below what it was, but it's 4 points over what it was. And what do we see happen? The price fell a lot. Defaults went up. Defaults are still going up. Price is trying to rebound. And then if we bump it up even higher so that it's higher than it was before we started by 1 point, and we keep going, we see defaults go up higher. And then we reach some steady state out here that is probably not where we want to be, but that's where we are. Okay, so a lot of people ended up getting mortgages they couldn't afford if the rate was higher than the fixed rate they were given when they got them. They were just barely could afford it then. When the rates went up, there was a problem. Okay. Let's talk about reusing modules very quickly. So if you want to build one, you want to think generally and how it might be used. You want to focus first on the functionality. What do we want it to do, right? Think of it as a built-in function if you want. It can have multiple outputs though. So what does it do? What are its inputs? What are its outputs? And then we can build it. If it only has one output, by the way, we can turn it into a macro, and then we can use it as a built-in function instead of using it like a module. But let's talk about reusable modules to start. Let's pick a simple thing. We want the maximum value across the entire run. The input will be the entity we're going to find the maximum of, and then the output will be the maximum value so far for this run. Then we have to think about how we want to do it. We're going to need a stock. Anytime we want to keep a value that we remember as the model goes, we need to use a stock. And it's going to act kind of like a stock adjustment process. It's going to always adjust to a new maximum. So if we go find that somewhere here, by the way, we're going to use this in the last model. We have a stock. And we've set it up as a module output. You can see, actually let's go in edit mode. You can see it's a module output. I use a uniflow, so it can only go up, it can't go down. And its initial value is the initial value of what we were given initially, and then the change is just the difference between them over dt, so it changes instantly. And if we run this, we can see it's working. So it's a 1 dt behind, but it's working. And we can fix that dt delay if we want to make it more complicated, but let's not bother for today. But we can see it's actually working every time it walks up with the maximum value, and we should be happy that it's working. So we can go back to our mortgage model, which is here, and we can go into price. We can add a module, and we'll call it maximum for fun. And we can import into this module that file that we just had. Import maximum value. We can connect price to it. Oh, it'll even ask me where I want to connect it to. Okay, I want to connect it to input, maximum input. Great. And then I'll have a converter, which is my max price. And I can connect that coming out. And I can assign that to the maximum that's in there. And I can watch what happens to this, right? If we had time, I would actually do that. Here, we can probably do something simple here. Rather than going back to the interface and running through something complicated, we can turn this on to 1, and we can drop the interest rate here. Something like that. Okay, just to get it to run. And then we'll run it. And, whoops, it's in price. Run, 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 run. Okay. And our maximum price was 186, right? So we can use it that way. We could also just, well, I'll show you on the slide. We want to do minimum, we do the same thing, and we can, again, create a macro there, or there's now a built-in function called run max to do that, okay? Somebody just asked a really good question before I go on to the next level. Somebody just asked, is there an easy way to turn my sector-based model into a module-based model? So sectors are under here. And by the way, I still use sectors. Like if I'm building a really tiny model and I don't necessarily have a dynamic hypothesis, I'll use a couple of sectors maybe. Or I may use them inside a module to separate things, put things that are related together. So let's say we have a sector here. The sector is just right under the module. And let's just, copy some structure. I'll just copy all this and just put it in this sector. Wow. Okay, so that was bad. I shouldn't have put it right there. I should have moved it over. By the way, notice these variables that are called no names. These were the things that I had connected that I didn't use the ghost tool for. I didn't bother naming them originally. If I use the ghost tool, it always gives it a name that's not a no name. Okay, or in this case, converter 1, converter 2, which it would be. Anyway, here I have stuff in a sector. If I want to make it a module, well, this selects all, but very dangerously close to that is this button that converts it to a module. Dangerously close, it asks me, do I want to replace it with a module? If I say yes, then I have a module that has the name of the sector, and there's my module. So I can do that, but then I do have to manually go through and connect everything, which, you know what? Using the ghost tool is very fast to do that. I've done it many times. So just ghost across and ghost across, which is what you would have done between your sectors anyway. Okay, let's talk about hierarchy quickly. We're running out of time, but I think we have time to at least talk about this quickly in the next 5 minutes. So if you're building a hierarchical model, there's a blog post about this. You can draw the high-level aggregate reference mode and then a high-level aggregated dynamic hypothesis, and then drill down and do that each level. At each level in the module, draw another reference mode, another dynamic hypothesis, and keep going until you get to your stock and flow models. Build and test your stock and flow models, combine them, analyze the behavior, combine them in the end, and verify you're getting the reference mode you want for everything, and then analyze and perform policy experiments. So we're basically just doing this iterative loop for each module below. So if we look at this picture, this is my high-level dynamic hypothesis, and then for each module, I have another dynamic hypothesis under it, and then under these modules, I have stock and flow diagrams. I might have more modules. So just to make sure you have the picture, here's a reference mode at a high level of the U.S. healthcare system. And this is the dynamic hypothesis for that, where healthcare delivery includes physicians, emergency room, in and outpatients, just reduced to this to help us see what's going on. As population goes up, healthcare delivery goes up, technology gets improved, population goes up because life expectancy goes up. As technology gets improved and more money is spent, as there's more healthcare delivery, more money spent, more technology is delivered, more technology leads to more healthcare delivery, which gives us more money for more tech, blah, 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 blah. Goes on and on and on. Okay? So let's look inside this, which is actually the full model is this. Okay? So that healthcare delivery were these 4 modules. So physicians, we're going to look inside physicians. So we have a reference mode for physicians, and a response to a drop in price so here price goes down, visits go up, capacity is held constant by the American Medical Association. So price goes back up and visits goes down again. So as physician visits, our dynamic hypothesis is as physician visits go up, our utilization goes up, pricing goes up, visits goes down. Okay? And if we go back to the model here, and actually we can go in, so here's that actual physician visits dynamic hypothesis, and here is the structure underneath. We can navigate through this. Here we have something larger. We're going to want to use something. So we can go look at capacity directly. We can go look at physicians directly. Okay? And we'll use that again in a second, because the next example, I didn't show you the reference mode, but if we look at inpatient care in there, as visits go up, utilization goes up, length of stay goes down, and then we get some length of stay related complications, which lead to more inpatient visits. Okay, and of course, here we can just go to that. It's right here. We can look at any individual module in there, etc. Finally, let's look at one more example before we stop looking at hierarchical modules. The technology part of this does not have any dynamic hypothesis. It's just structural disaggregation, right? So we're not doing behavioral disaggregation. We want to break it up because the structure makes it easier for us to work with. So in this case, we have a fairly big piece of structure. We could have put both of those in sectors if we want, but it's easier to deal with them by putting them in modules. There are a lot of modules in here, by the way. Okay, the last thing I want to talk about before the Q&A is module ghosts. It's a new feature. We added it in 3.5, I think, or 3.6. Anyway, module ghosts are very handy because we can use them to help organize our diagrams a little better. And they only allow outgoing connections just like any other ghost. But let's look at this picture, and we just saw this picture over here in this model, right? This is this picture, okay? It's a little, this accounting is kind of in the way, right? Of course, if we move it, we're going to lose some of the direct links here. There's a loop here, but maybe it's not that important, a loop, it's hidden. So can we clean this diagram up a little bit? And yes, we can by moving accounting and ghosting all the things that go into it. So I took accounting out of here. I'm moving it down here by ghosting the other things. So here's accounting at the bottom now, and then all of these are ghosted to go into it, and I don't need to have it cluttering up the diagram there. Again, I did lose interior loops, but you'll also notice I'm not calling out those interior loops here. I never was. The loops that I'm concerned with are the loops I showed you originally when I had the highest level dynamic hypothesis. So thank you for joining me today. We have 13 minutes for questions. The first question is, they're wondering how you make a graph for graphical functions, which is kind of beyond the scope of this particular presentation, but I can very quickly show you how to do that while we're waiting for other questions. Let me go to the new model I had over here that doesn't have any structure. So, by the way, someone just asked the inverse question. Can I convert a module to a sector? Not by pushing a button. You need to copy and paste, which you can do. Very few people do that. But if you wanted to, you can just copy and paste. Right? So copy all the structure inside the module and then paste it at the top level, as I just did, by the way, for the example where I showed you went into it, right? The way I created that sector was I copied from inside the module, I put it in the sector. Then I created a module from it by pushing that button on the sector. So when I create a graphical function, let me just say, I'm not going to go into the details. I can spend an entire hour just talking about graphical functions, but I do want to show you that when you make a graphical function, and when I turn it on, it's going to automatically make it related to the equation tied to the single variable if I have a single variable there, or if there's nothing, it'll use time. I need to set the X scale, I need to set the Y scale, and then I can choose, and I usually continuous, I don't need these other, but sometimes I want extrapolated, sometimes I want discrete. I may need to change the number of points, but let's not worry about that right now. I would always start, since you are not familiar with this, with one of these best practice shapes. Okay, so this is down, right? This is technically called convex, I believe, and you can set the steepness here. This would be concave. Oh no, it's the other direction. Sorry, convex in the other direction. This is concave, and you can set the steepness on these. Okay. So I would pick one of these shapes, and then you can pick linear or not, and you can pick S-shaped. Again, how curved is it or not? You can do that based on after you already set your scales. And you want to make sure that your points go through the important places. So the endpoints need to go through where you want them to go through, and the midpoint, you usually have a 1-1 point. You need to make sure that you do have a 1-1 point, and you can set that here. But that is a very long thing to go through. Okay, a lot of people asking about the video. Yes, there will be a video. There'll be a recording. Is there a way to automatically create a reference mode from a module map? Well, so that's the wrong way around things, because the reference, the dynamic hypothesis explains the reference mode. So you have to have a reference mode first to draw a dynamic hypothesis. But you will notice that when we ran the output that we had from that mortgage version of housing supply and demand, the output from that would have matched our original reference mode that we drew. So by running the model, we get a reference mode. Well, we don't get the reference mode. We get the the output of the model, which is supposed to match our reference mode. But we always start with our reference mode. That defines the boundary of our model, and it defines the behavior we're trying to replicate. The version of Stella to purchase to do with this, Hillary can probably help you with a link to that. You can use that with any version of Stella that we have had for a long, long time. Module ghosts are new, 3.5 or 3.6. It's very new, but everything else has been there for a long time. So I was asked, we showed an example of building a hierarchical model. Is there a model overview which shows the elements in the hierarchical structure? I'm not quite sure what you mean by an overview. You mean that would show the tree diagram or something? There is not. If you mean that shows us the modules, all the modules and how they're related, well, we do have that. So this is a tree view, by the way. It's called a tree view, but it's not an actual graphical tree structure, right? So I don't know if that answered your question, Thomas. If it didn't, you can clarify. So, and the hierarchy is here, right? If I close this, everything under there is gone. Close that, everything under there is gone. Next question is a good question. If a module is used in several places in the same model or across different models, is it possible to change the module and have that change updated in all places? When it's in a separate file, you can change that separate file. The problem is that separate file will typically be saved in the modules folder for that model, so you'll have to copy and paste it around to do that. I've done that before. I'm trying to remember what the easiest way to do that was. There's a way to make that work. I don't remember. With the file system, I mean. Oh, thank you, Boris. Great. So I did answer that. So there's a lock. Does the lock on a sector, what does this do? Does this select it for running? No. The lock makes it so when I put stuff inside of it, so I'm using name-only converters in this specific model. Like, notice it can fall out, but if I lock it, it's going to stay where it is. That's all the lock does. If you want to run specific sectors, you go to partial run simulation and say run selected sectors, and then select what you want here, just as we did for the modules. Okay. Is there anything I didn't answer or other questions you have? No one asked about urban dynamics. I'll let you figure out the feedback loops there. So someone's asking if there's a set of extensive set of model examples, Stella model examples, still available as there used to be. So yes, they are under, again, if you go to our website, go to resources, sample models, they are all there. And there are also several on our online documentation, which is at icsystems.com/help. As far as the urban dynamics model, can I share it? I actually got permission from Jay Forrester years ago to be able to share that, and I regret to say I haven't gotten around to it yet. So I will try to do that. And what are the models used, the climactic models used in GIS? I'm not sure what you're asking about there. If you do go to our sample models, you will see that there is a version of C-Roads up there. Not in our sample model, sorry. If you go to our showcase, which is under I can go to our website. Well, whatever. Under solutions, I believe we have our showcase, and there is C-Roads there if you want to play with it. Oh yeah, the sample models link, by the way. Yeah, thank you, Hillary. The sample models link I showed a long time ago for everybody else. I'll just put it back up again. Here. Yeah. It's right here. These are our sample models right here. That's not the showcase. I don't know the showcase link off the top of my head. But help, you can just say icsystems.com/help. It'll take you to our current help always. Is there any process approach published to model using modules? So again, there's a blog post on the blog. If you go to the blog and you type in modules, you'll find something there. And I think that's probably the most thing. There is a paper at one of the ISDC conferences. I probably should have put a reference to that in here too. That's probably about it. Okay, so to see it again, there's going to be a recording. We'll probably send that out next week. I believe it's on the schedule to be sent out next week. And thank you very much. I'll see you guys later, and have a great afternoon, evening, morning, wherever you are. And hopefully I'll see some of you at the ISDC. Thank you, and bye.